Well, let's solve problem 19. I can tell you that it is a really advanced problem for AMC. It's more the level of AME, especially because you have here like very interesting idea and pretty large number. It is from AMC, but it's still like of the next level. So let's look. Triangles ABC and ADE have areas 2007 and 7002. You have coordinates of point B, which is at origin coordinates of points C, D, E, and you need to find the sum of all possible x coordinates of A. Okay, so at this moment, nothing is clear, so we need to make like a picture that will explain us what is happening. So here we have y-axis, here we have x-axis, and here let's mark points that we have, because we have point B, which is at origin, so B is somewhere here. So next, C is on x-axis, it has coordinates 2 to 3 and 0, so C is somewhere here, it has coordinates 2 to 3 and 0. Next, you have D, which has coordinates 680, 380, so D is somewhere here, 680, 380, and eventually E, which is 689, 389. You see, E is pretty close to D, so we need to mark it on the picture 688, 398. And no one tells you here what are the coordinates of the point A, right? So you don't know. The only thing you know that ABC, this triangle ABC, has an area of 2007, and another triangle ADE has the area of 7002. Okay, so if you are told that BC is this segment, which has obviously the length of 2 to 3, and A is some point such that the area of triangle ABC is 2007. Well, what is the locus of all points A? If you know basics of geometry, you can understand pretty quickly that it will be this line which is parallel to x-axis on a certain distance from x-axis. Really, for example, you need to find only one point A. Let's assume that you are looking for only one position of A, and the area of this triangle can be calculated as this altitude h times the length of BC, right? So it will be h times 2 to 3 over 2, which is the area of triangle ABC, and it should be equal to 2007. And after that, you find h. In this case, so h will be 2007 times 2 over 2 to 3, and the numbers here are chosen well, so 2007 over 2 to 3 is simply 9, so it's 9 times 2, which is 18. So this distance h should be exactly 18, and if you draw a line which is parallel to the x-axis on the distance 18 from x-axis, any point from A on this line will have a property that this distance is 18, and therefore the area of triangle ABC will be what you need. It will be 2007. However, it's not the only line with this property. Also, you can draw the line below x-axis, and the distance will be exactly the same. So if this distance is 18, in this case, any point A on this line also has the same property that the area of triangle ABC is 2007. So the locus of all points A on the plane such that the area of triangle ABC is 2007 is these two lines. Any A on this line or on this line has a property that the area is 2007. So now the second condition, the area of triangle ADE is 7002. We will use, of course, the same idea. However, you see that DE is not such a good segment, because E and D, they have a property that delta x here, difference in x is 9, and delta y here, the difference in y is also 9. If delta x is 9, delta y is 9, it means that DE is simply 9 times square root of 2, right? So it means that the length of DE will be 9 square root of 2. So just let's write it here, DE equals 9 square root of 2. And if you want to calculate the area, you will do the same. You drop perpendicular from A to the line that contains DE, and you multiply the length of this perpendicular times DE. So 9 square root of 2 times the length of the perpendicular over 2 should be 7002. So let's calculate this h. H will be equal 7002 times 2 over 9 square root of 2. Here are square root of 2 and 2 I can divide like this, and it will be square root of 2 here. And 7002 obviously is divisible by 9 because sum of digits is divisible by 9. And let's quickly divide it. 7002. Let's quickly divide it by 9. It will be 7 minus 63. 7 minus 63, it will be 778. Perfect. So 778 square root of 2 should be the necessary distance from A to this line. So let's draw this line through DE. Let's mark it with some like color that will be like more pronounced than black color. Maybe we'll use purple one. And let's just connect points D and E. We will extend this line a little bit like this. And the necessary distance from point A to this line should be pretty large, should be 778 times square root of 2. But of course, we will not do it up to scale, just not to waste the space. We will tell that it is like exactly the same story, that A can be on one parallel line, on the one side, on the one like half plane from this one, or A can be somewhere here, right? So two lines, they are this line is parallel to this line, and the distance between these two lines is 778 times square root of 2, and the same is here. Let me also make this line a little bit further, like this. Okay, perfect. So now it looks like this one parallel to this one, parallel to this one, and the distances here are 778 square root of 2. And if A is here, or if A is here, the distance to this purple line will be exactly 778 times square root of 2, and the area of triangle ADE will be 7002. Perfect. As you can see here, we obviously have a parallelogram. We have these two parallel lines, these two parallel lines. Let's just finally connect all of that. And so let's understand what are the possible options for the point A that really works for us. Because look, from the first conditions about the area of triangle ABC, we know that A should be located whether on this line or whether on this line. Or from the second condition about the area of triangle ADE, we know that A should be located here or here. So, what are the possible locations of A? It can be located here, here, or here, and here. Obviously, here we have 4 possible points where A can be located. One point, another one, and another one. Eventually, you have only 4 points on the plane that satisfy your condition. For each of these points, everything will be fine. So, here are possible locations of A. And you need to find the sum of these x-coordinates. For these points, the sum of their x-coordinates. If you try to find these points directly, you will spend a lot of time, because you see, you will need to find the equation of this line, and then when this line intersects this one and this one. So if you do it manually, you will spend really a lot of time, because at first you need to find the equation of this line, which is pretty simple. We will do it in the future, but after that you need to to find another line which is on the distance of 778 square root of 2. So you will spend a lot of time, and we are interested to solve the problem as fast as possible. In this case, let's do some tricks. We understand that this figure is a parallelogram, so this point has coordinates x1, this point has a coordinate x2, this point has a coordinate x3, and this point has a coordinate x4. Well, for us, for example, it's difficult to tell what should be x1 plus x2, not obvious at all. However, we know the property that if you add x1 plus x2 and divide it over 2, the arithmetic mean of these numbers is exactly in between of these numbers. And what is in between? Well, this line is on the same distance from this two line. This line is a midline of this parallelogram. So x1 plus x2 over 2, it is the point like here. So x coordinate, if you take this point, x coordinate of this point will be exactly x1 plus x2 over 2, because it's exactly in between. Similarly, if you extend this midline a little bit, so it intersects this segment exactly in between these 2 points, and x3 plus x4 over 2 will be x-coordinate of this point. So let's go to this point, and x-coordinate of this point is x3 plus x4 over 2. Perfect. So this point has this coordinate, this point has this coordinate, and you can continue the same idea. For example, this point is exactly like in between these 2 points. So here is a segment. It is also a midline of parallelogram. Why x is a midline of parallelogram? Well, obviously, because this line is parallel to this one and they are on the same distance from x. So this point is exactly the midpoint of this segment. And if I take this one plus this one over 2, again, arithmetic mean of these x coordinates, it should be exactly x coordinate of the point of intersection of this purple line and x-axis. In my picture, this point looks like it's C. It's not necessary. C, we will go. It's just by coincidence. So this point of intersection of this line and x-axis has coordinates x1 plus x2 over 2 plus x2 over 2 plus x3 plus x4 over 2, and all of that over 2, which is obviously equal just x1 plus x2 plus x3 plus x4, and all of that over 4. Great. So this point, which is exactly in the middle of parallelogram, is a midpoint of parallelogram, it's just intersection of two midlines, it has these coordinates. And this point is very easy to find. It's the point of intersection of this purple line and x-axis. What is the equation for this purple line? Or in order for you not to waste time, you can guess this equation very fast. You see, the difference between x and y here is 300. So x minus y is 300 for this point, and x minus y is 300 for this point. Therefore, this purple line has an equation x minus y equals 300. This is it. And you need to find the point of x intersection of this line. So in this case, here y equals 0, and therefore this coordinate of intersection is 300. So this is 300, and therefore this is 300. And from here we get that the sum of these four coordinates equals 1200. And 1200 is the right answer for this problem. So this is it. Let's go to the next one. Okay, let's go to the number 2. It will be a pretty simple geometry, but in the same time it's a pretty interesting one. Okay, so corners are sliced of a unit cube so that 6 faces each become regular octagons. What is the total volume of removed tetrahedra? I will call it just removed pyramids. So let's make a picture. We have some cubed, unit cube, so all the sides are, each edge is 1. So cube looks like this. After that you cut corners of this cube, and here after that you get a figure. Each face of this figure is a regular octagon. Let's understand how it may happen. So if you cut, for example, here this corner, this pyramid will be cut off this corner. Here from this corner you also cut pyramid like this. From this corner you also cut pyramid, and from another one. So as you can see, we may not draw all the pyramids, but you see what is happening, that for example the face that is on the bottom, after you cut 4 pyramids here on corners, what figure do you have like on the bottom face? You have an polygon, and how many sides does it have? It has 4 purple sides and 4 black sides. It's definitely an octagon, and they tell us that it is a regular octagon. So all the sides of this octagon and all the angles are equal, and the same happens on this face, on this face, on this face. After you consider this scenario, you will figure out pretty quickly that you should obviously cut same pyramids everywhere. Only in this case you will have same faces, same octagons on each side. And what pyramid should you cut? In order to understand what pyramid should it be, just let's look at the bottom face, which is a perfect square. And here it will look like this. So this corner will be cut, this corner will be cut, this corner will be cut, and this one will be cut. And this figure, remaining one, is a regular octagon. What is the angle of a regular polygon? You remember the formula, like n minus 2 times 180 is the sum of angles of a polygon. If it's a regular polygon, you should also divide it by n. And in our case, we have an octagon, so the formula will look like 8 minus 2 times 180 over 8, and so it will be 6 times 180 over 8, and if you like make like this, it will be 4. Here you will get 3, and 180 over 4 is 45. 3 times 45 is 135. It means that each angle of a regular octagon is 135, and it works for us really. If it's 135, this is 45, this is 45, 45, and here is 45. So this is the right triangle, right isosceles triangle. And So for me, the main question, what should be the parameters of this angle that I cut here? So obviously cut goes like this, so this angle is 45, but if we have a unit cube, for example, this one is 1, what portion should I cut here and here, so that is, so this figure becomes a regular octagon? And this question is very easy to answer. For example, if this is, for example, x, it is a parameter of my cut, so I cut x from the vertex, so it is also x. In this case, if it's a right isosceles triangle, it is x times square root of 2, this one, x times square root of 2, and it should be equal to this one. And if this is x, and this one should be 1 minus 2x. And if we want to have here regular octagon, this side should be equal to this side. On this side is 1 minus 2x, and this side is x times square root of 2. So we have an equation. 1 minus 2x equals x times square root of 2. From here, 1 equals x times square root of 2 plus 2, and therefore x equals 1 over 2 plus square root of 2. Perfect. So now we know exactly what are the parameters of our cut. In this case, this figure is a regular octagon, and obviously everything is the same for every face of our cube. Now we need to find the volume of removed tetrahedra. Obviously we have here 8 pyramids removed on the corners. Each of all they are like the same pyramids. They are totally the same. So the total removed volume is 8 times the volume of one pyramid. Let's look at this pyramid, for example. Let's zoom it a little bit. So we know this this side, that this side is actually x, right? This is x, and this is x, and this is also x, right? So, and if you look at the properties of this pyramid, this edge is actually an altitude, right? So maybe it's not a perfect picture here, but this one is perpendicular to the base, to this triangle. And if you want to find the volume of this pyramid, it's super easy to do. You just need to multiply this altitude, x, times the area of triangle on the bottom, which is x times x over 2, because it's like a right triangle here, and also altitude times the area, and don't forget 1 over 3, this coefficient for the volume. It is altitude, the area of the triangle, and this area is 1 over 6 x cubed. Perfect. And this volume is 1 over 6 x cubed, and x in our case is this value. So the result will be 1 over 6 times 1, 2 plus square root of 2 cubed, and also it's the volume of just one pyramid, and you have 8 pyramids like this. So the total number, the total removed volume, will be 8 times this one. 8, when you multiply by 1 over 6, you will get 4 over 3, like this, and 1, 2 plus square root of 2 cubed. So let's check if we have this answer among the answers that they offer. You see, we don't have. So we have probably the proper result here, but we need to work a little bit with this number to find out which of these numbers work for us. And it is a typical for the last problems of AMC. Sometimes you get the right result, but you need to work a little bit with it to understand how it will look at the end. So here we will use the formula a plus b cubed for denominator, right? This formula is a cubed plus b cubed plus 3a squared b plus 3ab squared. Let's apply it here for the bottom part. 1, and here it will be 2 cubed, it will be 8, plus square root of 2 cubed, it will be 2 square root of 2, right? And plus 3 a squared b, 3 times 2 squared, 3 times 4, it will be 12 square root of 2, it's 3a squared b, and finally 3ab squared. 3 times 2 will be 6, times this square, it will be times 2, it will be plus 12. And this sum on the bottom looks like this. It will be 20 plus 14 square root of 2. Great. So, and as you can see, 12 plus 14 square root of 2, we can also divide by 2 on the top and on the bottom, so it will be 2, 3, 10 plus 7 square root of 2. And again, this is a little bit better, but it still doesn't look nothing like these results. And in order for us to get rid of these square roots on the bottom, we will multiply this fraction by 10 minus 7 square root of 2 and 10 minus 7 square root of 2. It's also like very common thing. So let's multiply it, and what we will get on the top? 2 times 10 minus 7 square root of 2, and here we will get the difference of squares, right? So it will be 3, and it will be 100 minus 49 times 2, which is 98. 49 times 2, yeah, 98. So this one will be 2, so it is 2 and it is 2, and the result is 10 minus 7 square root of 2 over 3. Let's check if we have this number. 10 minus 7 square root of 2 over 3. Yeah, perfect. It is the answer B. As you can see, this problem is pretty simple. The only thing you need to develop the right approach from the beginning, and you will quickly find out what pyramid you need to cut from each corner. And in order to find the volume of this pyramid, you should notice here that one edge is actually an altitude, and after that, the problem can be solved pretty fast. This is it. Let's go to the next one. Okay, let's solve the last one. It will be a pretty interesting and pretty advanced equation. I can be sure that I've seen something like this in math competitions of all times, so it's not a new idea. So for positive integer n, let s of n denote the sum of digits of n. For how many values of n? N plus sum of digits of n plus sum of digits of n is 2007. Well, looks a little bit complicated from the beginning. Well, the first thing, if someone tells you about sum of digits of n, you immediately remember the rule about divisibility by 3 and 9, right? So, and by the way, this rule can be a little bit extended. For example, if you look at n, you want to understand what remainder does it provide you when n is divided by 3 and 9. And you look at s of n, and if s of n, for example, like 25, right? When you divide 25 by 9, you have a remainder 7, and it means that this initial number n also has a remainder 7 when divisible by 9. And in the case if the remainder is 0, you get this rule about divisibility, so it's like extended version of it, and it helps in some problems. So in our case, you see you have a sum of several numbers here, and each of these numbers is a positive one, n is a positive integer. Obviously, if n is 2007 or larger, then there is no solutions. We tell that n is less than 2007, right? So these are only possible options for n. And for example, let me explain about this equation. If, for example, n equals 1888, let's understand how it works. What is the sum of digits of n? Is 888 and 1, it is 25. And what is s of n? It is the sum of digits of this number, which is 2 plus 5, which is 7. And the sum of these three numbers should be equal to 2007. Obviously, when you look at particular case, you see that the largest here is n, and s of n is significantly smaller, and s of n is even smaller. Well, let's make some estimations. What can be really the maximum value of this sum? Because we suspect these two numbers to be pretty small. Look, we need n to be less than 2007. What is the maximum possible value for s of n, the sum of these digits of n? Well, this s of n is maximum only for n which is equal 1999. Really, for this number, the sum of its digits is maximum, and therefore the maximum value is 28. So 28 is the maximum sum of digits. And what is s of n? Well, we are looking for the maximum value of s of n. We know that s of n, the sum of digits, is not greater than 28. So this one will be the sum of digits of the number which is not greater than 28. So the maximum sum of digits of numbers like 1, 2, and so on, 28, which are the possible values for Sn, which of these numbers has the maximum sum of its digits is obviously 28. So the maximum value is 10 here. Perfect. In this case, we have a very simple estimation. This one has a maximum value of 28, and this one has a maximum value of 10. So the maximum value of this sum is 38. And therefore, as you can see, n has to be pretty close to 2007. And it means that we have very limited options, very limited amount of n that we should work with. So we know that n plus some number a, which is less or equal than 38, equals 2007. And therefore, n should be greater or equal than 2007 minus 38. Perfect. So what is this difference? We will get 2007 minus 30. We will get 1977 and minus 8, 1969. Okay, 1969 is the minimal value of n that we should start with. So n should be greater or equal than 1969. And so as you can see here, we have very limited amount of options. N can be whether this number or a little bit larger or a little bit larger, and we can go up to 2007. Okay, so this number, can we limit our options? Because as you can see, if we do everything manually here, we have to work with this number, for example, and we will look, for example, at s of n. What is the sum of its digits? It will be 10, maybe it will be 25, right? So 25, and s of n, if we do everything manually, it will be 7, and 7 plus 25, it will be 32, plus 1969. Does it work for us? No, it doesn't work. Well, the sum is just 2001. Not enough. We need 2007. If we do manually, it can be a little bit tedious. Can we somehow even restrict all these numbers? Because now we are looking for the n to be in the range from 1969 to 2007. Probably 2007, of course, is not included. So this one, if you look at this rule that I told you at the beginning about this divisibility by 3 or by 9, so this one is divisible by 9, right? So what can be the remainder of n when it's divided by 9? When n is divided by 9, we can have possible remainders like 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so as you can see, n and s of n and s of n, they all have same remainders when divided by 9. It's like extended this rule about divisibility. And eventually it should be 0 here, because this one has a 0 remainder when divisible by 9. So all these numbers, they have same remainders when divided by 9. And for example, if each of them has 0 remainder, for example, n has 0 remainder when divisible by 9, therefore this one has 0 remainder, this one has 0 remainder, everything works out. So, for example, if n is divisible by 9, it works for us. If n has a remainder 1 when divided by 9, then this has a remainder 1, 1, 1, and this one has a remainder 3 when divisible by 9, but this one has a remainder 0, so this one doesn't work for us. For example, here, 2, 2, 2, 6 doesn't work for us. 3, 3, 3, 3, 9, divisible by 9, so 3 works for us. 4, 4, 4, which is 12, doesn't work for us. 6, 6, 6 works for us, so it will be 18, and 7, 7, 7, 21 here, not divisible by 9, and 8, 8, 8, 24. So now we significantly even restricted the amounts of n that we should consider. So here we should consider only values of n that are divisible by 9, so n is like 9k, or n equals 9k plus 3, or n equals 9k plus 6. As you can see, among these numbers, it's very significant, we reduced our job significantly. So what about 1969? Is it divisible by 9? It's not, and the remainder is 7, so the remainder is 7, so this one we could not even check, so it couldn't work for us. So the next number will be that is divisible by 9 will be this one plus 2. It will be 1971. It potentially works for us. The next one will be this one plus 3. It will be 1974. The next one will be this one plus 6. It will be 1977. Okay, and the next one, which is divisible by 9, will be this one plus 9. It will be 1988. 80. The next one, this one, plus 3, 1983. Now I will simply list all the numbers that are left, and we will go through this one. 1986. The next is divisible by 9, 1989. The next one is plus 3, 1992. The next one is plus 6, 1995. And the next one, which is divisible by 9, will be this one, plus 9. It will be 1998, plus 3 will be 2001, and okay, we are very close to the finish line. And the next one will be plus 6, it will be 2004, and the next one, which is divisible by 9, will be 2007, but 2007 doesn't work for us, simply still too large. So as you can see, we have only these 12 numbers, these 12 possible options for n that may work for us, and for each of them we should manually calculate this sum n plus s of n plus s of n, and to check if it is equal to 2007. So let's start from this n. So for example, 2004 plus sum of digits, it will be plus 6, and it is just too large, it doesn't work for us. So 2004 we throw away. 2001, it will be 2001 plus 3 plus 3, it works for us. Okay, so 2001 is one of our options. 1998, let's look at this one. 1998 plus the sum of digits. Here the sum of digits will be 27, and it's just too large, it doesn't work for us. Okay, 1995 plus the sum of its digits, it will be 18 plus 6 plus 24, and still too large for us, doesn't work. So this one doesn't work. 1992 plus the sum of its digits is 18 plus 3 plus 21, and it's too large, doesn't work for us. 1989 plus the sum of digits will be 27, and is it too large for us? Plus 9. So plus 27, it will be plus 26. Yeah, too large, doesn't work. Okay, 1986 plus the sum of its digits is 7 plus 8, 15. 15 plus 9 is 24, plus 24 plus 6, and if you add all of that, you will get just too large, so still doesn't work. So 1983, let's check with this one. For 1983 plus the sum of the digits will be 4 plus 8, 12, plus 9 plus 21 plus 3. Well, this one might work really, because this sum is 2004 plus 3, 2007. Yeah, this is one that works for us. 1980, let's look at 1980. The sum of the digits here is 18 plus 9. Okay, so let's look at this one. It will be 1998 plus 9, 2007. Works for us. It works perfectly. It's also working option. Okay, 1997. We have just very few left. 1977. So the sum of the digits here is 14 plus 1, 15. 15 plus 9, 24 plus 6. What can we tell about this sum? This sum will be 1990, well, 2001 plus 6. Yeah, it works for us. It works for us again. And 1974. 1974. Let's look with this one. What is the sum of the digits here? So it will be 5 plus 7. It will be 12 plus 9, 21 plus 3. So this one is 24. 1974 plus 24. Well, so it obviously doesn't work for us. And 1971. 1971 plus the sum of the digits, it will be 8, 9 plus 9, 18 plus 9. So 1971 plus 27. 7. Does it work for us? Obviously, it doesn't work for us. Yeah. So, and here you have only 4 possible values of n that satisfy your equation. As you can see, because we didn't try to consider each n separately, but we made some sort of filtering just based on the remainder of n when n is divisible by 9, we reduced our job only to 12 different values of n, and it was like a great, very helpful for us. And now we see that only 4 different values of n work for us, and D4 is our answer, because we are looking here for how many values of n this equation is true, and we found out that it is true for 4 different values of n, precisely for these numbers. Okay, this is it for today. Thank you.